Good afternoon, everybody. Just gonna ask somebody in the chat if it is possible for you to guys tell me if you can hear me. Just one person in the chat can do that. Marvelous. Thank you very much. Hi, everybody. Thank you for joining us. Let me share my screen and we can start on with the presentation. Let's do this one. Or let's do, yeah. And let us begin. Oh, okay. Let's put it here. And this. Marvelous. And do this one. There we go. Everybody, welcome once again. Today we're going to go over the new functions of the carbon footprint calculator. Here is a little agenda that I prepared for you guys today. Here it is. So first we're going to go over the team introduction for those that don't know a lot about Total Materia. Then we're going to go into the CO2 itself. We're going to introduce what it is for. We're going to introduce new developments and what we're planning on to do with it afterwards. Afterwards, we're going to go into the CO2 demo. And of course, as like every other webinar, we're going to have a Q&A demo or a Q&A session in the end. Now, because we're all human, I know that it's probably going to look something like this. After every single part, if you have a particular question, I did include also a few interactables for you guys. But anyway, if you have any questions at any time, do reach out via the chat function. You should have a chat function somewhere there. And just type it in, I will see it. And if something, if I don't manage to answer every single one of it, we'll be able to reach out in the end. And as you can see by the last thing, which is the part 4 of the agenda, we're probably going to have the awkward silence in the end, but hey, we're human. Of course, that happens. Now, here is the first poll of today. Now, some of you are using the Total Materia or have been using for some time. Some of you are following us for a particular time. And you probably already know some of these tools presented here. And the questions above is the questions of the that you're going to have a poll right in front of you in a second. Here you go. If you are, of course, familiar with all the Total Materia tools, just mark the first one. Yes, of course, we're familiar. If you don't know every single one of them, 2/3, let's say, of course, that's the second one, good half, and so on and so forth. If you don't know any of them, of course, you're a new person here. That's absolutely fine. If you have also been using Total Materia, but you also don't know all of the aspects of it, of course, that's why we have trainings, that's why we have organizations, polls, webinars, so on and so forth. Wow, so it seems that we have more new people basically here today than ever before. That's good. Now I know in how much detail I actually need to go through when I'm explaining Total Materia at large. Thank you all who submitted that. All right. So let's go then a little bit deeper into Total Materia at large. Horizon is what we call here a mothership. Horizon is that part that contains this biggest amount of data that you see right here. I did go through all of the standards. I did calculate every single one of them. It is 63,239 of them. And they provide the most amount of data on about 70 or 80% of the materials that we have inside of the Total Materia, inside of the Horizon part. And of course, everything is done through official sources. We purchase the standards, we find them, we implement them inside. Next to that, we also, of course, also have the proprietary sources coming from producers, coming from books. We'll bridge that part a little bit later when we go into the cross-reference section. Connected with the Horizon, or the biggest installment that we have is the integrator, followed by the Horizon. And that is your sandbox when it comes to Total Materia. right? So if you're a big company, you have your own tested materials, you have your own internal procedures, so on and so forth. This is everything of those implementations, anything of the tested materials can be implemented inside of the integrator. But along with that, you have our data sets. So it's basically best of both worlds. You organize how your engineers want to see or discover materials or play with materials at large. Because having the 600,000 materials for some companies is a little bit too much. Therefore, an integrator, they choose to limit the amount of materials they can see or they can play with. Of course, you have Horizon in there, you have tools in which you're supposed to be limiting all of your material selection, but in integrator, you can go that one step further and use your own tools, your own materials, your own whatever basically you think about can be implemented inside. Some of the things are custom, but if you're interested in integrator, we'll be able to speak about that a little bit afterwards. And predictor is the material that's one of the newer tools, basically right here, and that one is for predicting values. Of course, it happens that particular materials, especially newer materials, they don't have all the testing done. Some of the older materials happens the same. Uh, and predictor is there to cover those gaps. We have been training an AI to be able to predict particular properties based on everything that we have inside of Total Materia. So we gave an AI our biggest data set from Horizon, and we taught it how to measure particular things so that you can have these gaps closed and in the end either have a knowledge before you send material to be tested or have knowledge or increase the amount of information that you have on the existing materials inside of your data mix. And the green line, this is what we're going to be speaking about today. This is the sustainability and compliance part that we have inside of Total Materia. This is where the CO2 is, and I'll tell you everything else that there is about green line today. I'm not going to go into too much detail, just overlay of everything that is in there. Now, if you wish to have a little bit more knowledge about any one of these, so today we're going to go over the green line, but if you want to know anything additional about these four, you can of course tell me and we'll reach out to you afterwards. So if it is a yes, you can select the other one. If it is a no, then that's absolutely fine. Take a second. This is primarily afterwards will come out via email and you will tell us exactly what you're interested in, what is the problem or an issue that you're facing, if it can be solved. Of course, we are here for you. Just take a second. 2 more seconds. 1 more second. Right. Thank you all. Let's go one step forward. And let's dive into the carbon footprint. So the carbon footprint calculator actually got launched in December, but what we are here today is to look at that cross-referencing function. This is probably what everybody came here today. But one thing is very important that we have to say is that Total Materia, just like this last part here, is calculation from cradle to gate. We're not able to calculate anything beyond that because we don't have sufficient amount of data to be able to provide you with particular research, particular numbers, because there are many things that are not regulated. There are many things that are unknown to us. And therefore, we settle, for example, from cradle to gate because all of this information or 29 different sources that we have so far are inside of Total Materia. And I'll explain how we do that afterwards. But this is one important thing that we have to mention, which is from cradle to gate, not from cradle to grave. Right. In our existence, so we have been on the market for 25 years, and we are noticing that there are two particular trends at the moment, and these are the tools or these are the sections that every single project has to go through. From material selection, in the end, by designers finish the job, they go to supply chain, sustainability, compliance, and so on and so forth. This used to be two separated sections of material selection in any single company. So the old one used to be this. You give a designer a job, they come up with an idea, they come up with a material that's going to do the job best for that particular project. in the end, it goes into compliance, sustainability. They make the report, and that's pretty much it. They ship out whatever they need. However, today, because of all the regulations, that's starting to change. Because all the materials that we used before, we're coming to that standstill where we have to now check which material is going to be better regarding CO2 calculations. So now designers or engineers, mechanical engineers, have to do the thing vice versa. Whereas particular projects have to start with the CO2 sustainability and compliance, and then only afterwards they go into design. Or the designer already needs to know if that number is going to be lower by what they have been using before. So this is the trend that we have noticed popping out about 5 or 10 years ago. And this is why, for example, we started also moving in this direction. Now, if that is the same inside of your company, if you are also still in that old section in which designers do their job, the other compliance team do their magic afterwards, that is perfectly fine. Or is it, for example, the same as I said, where designers, engineers, mechanical engineers also have to have knowledge about CO2 sustainability compliances, these amount of things is what you're going to tell me basically just now. And here you go. If it's the same, you tell us basically it's the second one. If it's the same as the old one, it's basically going to be the first one. If designers only do their job, if you guys have to look into compliance sustainability, that's going to be the second one, the business focus. And something in between is understandable. Not every company does it absolutely the same. It's hard to pinpoint one particular thing. But you have a designers, or for example, a lead designer that takes a look at that, and while everybody else do their job as in general. Just a second. Interesting trend. Some of the people are still using the old variant where designers only do the job. I'm very happy for you. You're quite lucky, and everybody else is either kind of CO2 focused, compliance, sustainability focused, and something in between. Okay. Yes, as I said, engineering is kind of a little bit shifting more towards that. When I was in the university, we didn't have to think about sustainability, but it was something, for example, that was hanging that it would need to be done sooner or later. And the time has come, unfortunately. Right. So here is the green line at large, what the green line covers and what we're going to be speaking about today. Now, CO2 calculator is, of course, a separate part connected, or what it used to be was the LCA that has 41 indicators inside. This is where you were able to calculate the toxicity, energy demand, the ozone depletion. All of these sections used to be inside, or they are still inside. This is what carbon footprint used to be. However, on companies' requests, we have developed this CO2 calculator specifically for their use because, of course, it was needed. It had to come out sooner or later. The other things that we have is the compliance assessor. You put in a list of materials, you select the compliances you're working with, and of course, it tells you if it's compliant or if it's not compliant. Certain engineers, for example, their part of the job, this is something that they need to have, they must have. The other one is the BOM assessor, and that is something which is going to also have an implementation of CO2 calculation inside. So particular companies, they work through bill of materials, and what they like is to set up everything about the product and also calculate CO2 inside as well. So this is something that is non-existing at the moment, but we are working on implementing CO2 calculator with the bill of materials. Right now, we're also doing an overhaul of bill of materials. There are certain things that was also demand inside, and we're working on it just as well. Right. So let's look into why, how, and what is the premise behind all of this. CO2 calculator has all the reference data just like the Horizon. So it's working with the same information just like you had. All the references, all the properties, everything else is basically the same. In there, of course, you have connected with that is choosing the scrap content, choosing the country, choosing the transportation, manufacturing procedures. and so on and so forth. I'll show that in a second. But what is very important is the 29 different articles or 29 different sources that we have collected that stand behind that calculation that you have within. So this is basically the trust in results that you receive. What we are trying to do is lower the stress or lower the need for CO2 engineers to have to dig through all of these 29. We do that for you. So this is basically the same premise is for the carbon calculation, the advanced searches that you have in Total Materia. You place in your criteria and the proper material that can fulfill this criteria pops out. All the references connected with materials, testing data connected with materials. We often get questions, is this actually true? Can you check this for us? And we do that for free as long as you have a license. And we're trying to do absolutely the same thing, or we're doing already the absolutely same thing for CO2 calculator. Right. So let's go into the features and what it can do. This is a picture that one of the engineers gave to me when we started the creating the CO2. This was how we envisioned it to look like. This was just a pre-build, something that we constructed together to see how everything is going to be matching. And this is how it looks today. And that's what we're going to be playing with. Right. These are the tools which everybody wants to take a look at. So the first thing is, of course, choosing the reference. That's one important. Actually, that's the second part in this list. Choosing the reference you're working with. Depending on the reference, depending on from where you're ordering the material, depends the chemical composition. So first you would choose the chemical composition, the reference, and then afterwards you go into the calculation for the manufacturing, processing, and transportation. Easy as that. Every single group of materials have their own sets or their own things that you will be able to select. I'll show you that in a second. And then afterwards, if you're playing with bill of materials, you will be able to import that into the bill of materials, or through bill of materials, you'll be able to calculate just the same thing, excuse me. And of course, in the end, if you're trying to see the previous CO2 calculations and to compare it versus the cross references in Total Materia with other 600,000 materials to find the appropriate exchange that has a smaller CO2. This is the newest one that got released about, I believe, a month ago. And it works exactly the same, just like in Horizon, but we'll show you that in a second. Some of you still don't know, for example, how the cross-referencing is set up. And these are the tabs that you would be able to see if you played with Horizon in general. So if you open a material, there is a separate tab, cross-referencing, and inside you would be met with these 7 tabs. Seems simple enough. Identical and official are given by the standards themselves. So either the standard that from which material you're viewing, for example, the ISI, is telling us, yes, our material is similar to these ones. Or other standards are telling us exactly the same, just in an opposite way. Our material is similar to this one that we have, for example, in AISI. We have a composition 100%, pretty straightforward. And then we have other sources. Now, this is straightforward. It's from catalogs, books, anything that we will manage to get our hands off separate from standards, material producers, laboratories, so on and so forth. And in the end, we have this implicit. I hope this isn't too small. There we go. We're back. So to make the things a little bit simpler, I created this graph of how it actually works. Let's just move it forward. There we go. So this is the simplest explanation that I can think of. If we have a 304 AISI material, and the official equivalence through official sources is this Japanese one, the SUS 304. That's the official one. Both of them agree upon this. If a producer from some country creates a material and calls it 304L, and they state that their material is similar to this SUS 304. What does that mean for 304 AISI and 304L? Especially if none of these two official, the first two materials, did the testing, any particular testing. As soon as 304L states that they're similar to 304 SUS, we can also link it through 304 AISI. And that means that any laboratory or any proprietary source that does a particular testing, you would be able to link all of these together. So you're basically, from a tunnel, you're creating a whole field of possibilities in material selection. And this is what the cross-referencing in carbon footprint is supposed to do as well. I see a few questions. I'm going to be able to answer it in a second. Just a second. I need to finish this part. And this is the last one, which is a smart cross. And it is an algorithmic kind of a search in which you will be able to specify, do you want it more to be towards composition or more towards properties and so on and so forth. You should just take a look at it for a second. It's going to be pretty much self-explanatory. Moving on. Right. And the last function, for example, that also got released or got imported is the export function. And just underneath, you can see, for example, all the tabs presented just like we did in the upper one. So the bottom line is the export in Excel that you receive once you did all the calculations. And above, you have that list of materials that we're going to be playing with as well today. And while you look at this, I'm just going to take a look at a few messages that everybody sent. Right, so official and identical, somebody's asking, and vice versa. So official is usually provided or identical, was it? It's actually available on the website. But one tells us, if you're looking at 304 AISI, the identical, for example, would be given by the AISI standard. And the official one would be by other standards. So for example, if the Japanese standard tells us that their material from a Japanese standard is similar to the AISI one. That's the difference between these two. And there was, I guess you've mentioned 29 different sources of data. Could you name a few? Yes, I'll show you that in a second. It's in the bottom in Total Materia. Regardless of in which tab you are, you have references always at the bottom, and I'll show you that in a second. Right. What we want to work on afterwards, and this is going to be one of the last slides, is these two things. So that dashboard has already been developed. It was actually planned afterwards. Dashboard has been developed, but this material duplication, so if you, for example, want to make a duplicate and test another route or other processes, manufacturers, you will be able to select it, or you will be able to duplicate the material and then do this basically the same calculation. This is not inside yet, but it is planned. It's supposed to come afterwards. So we moved certain things because of the timeline, and but it is planned. Don't worry. Right. So let's go into the Total Materia. Here we go. So my big screen is actually there, so I'm going to go a little bit sideways, but let's pull a list of materials and show you what is available. So here is my list that was created actually for the previous carbon footprint webinar. We need to add it into a material list builder and then push it into the carbon footprint. In this list, we have this famous 304 material. We have this 6061 aluminum, grade 1, titanium, and a polymer PA66. 4 different sections, 4 different things. And what you will note is that every single one of them have a different processing. So ferrous alloys will have their own list of possible processing. Non-ferrous alloys will have their own. Titanium will have, so every single part have their own things to play around with. But first, you would choose the reference. What is the reference that you're playing with? Here, of course, 304 has many references, but if you see its references, the chemical composition changes, and based on the chemical composition is what we do the carbon footprint on. So be sure to select that afterwards. Once done with that, we go into manufacturing, processing, and transport. But to answer that question that we had, that Sude asked about the references, once I do the calculation, the references are going to pop out in here. So if I do, for example, without anything, if I just take the global averages here in the bottom, We have all 29 references. There we go. Was I correct? 28. My apologies. 28. And if for example, you need extracts from any of them, of course, you can always reach out and we will be able to send these extracts from the calculations, how it is being done, so on and so forth. We had this question before, and I have a separate Q&A file that I'm going to send to you afterwards, where people ask the question, especially about this: how are we so sure with the accuracy of the data? That question, for example, is very popular, and I will be able to share that file with you in the end of the webinar, or after the webinar. I can send you the full list of everything, presentation, video, and so on and so forth. But here, for example, let's go into manufacturing and everything else. Choose from which country you're working with. If you're, for example, working from Germany, if you're working from Finland, Europe averages, you're not sure exactly from where, all of these are selectable. They are actually connected. Sude asks if they are also based on EcoInvent. If they're not or are based on EcoInvent, they are based also on EcoInvent. The EcoInvent is also a huge part, playing a huge part in this stuff. But if something else, we'll be able to reach out to you afterwards, Sude, and we'll be able to touch on this a little bit more. But they are based on EcoInvent as well. EcoInvent is in that list. So if I choose, for example, Europe, and we choose the manufacturing route. So is it going to be a blast furnace, electric arc furnace? If you're working, for example, you're not sure which one it is, or you know it is arc furnace, you can also select the recycled content, depending on who tells you how much or what are the usual recycled content that you use. If you don't have recycled content, you're creating a completely new blast furnace is your way. Save it. Processing, same thing. If you're making a pipe or if you're adding or removing anything from the material itself, you would also have to specify how much you're adding or removing per kilogram of the material. Pretty straightforward. If I do, for example, hot rolling, it's not going to ask you anything. Impact. Where's the hot rolling? There it is. Hot rolling. And then you select where it is being done. For example, let's say Germany, and I can add it. It doesn't ask you to add anything. It's pretty straightforward. But if I add, for example, milling, with a double L, milling, and I say also, for example, Germany, sorry, Europe, it's going to ask me how much is it being added or being removed. So if you're adding, for example, a coating or something, it's going to also ask you how much you're adding. If you don't know, this is usually the average, but anyway, you can always reach out to us and we'll be able to specify these things. So you save it, and of course, transport, depending on from where you're doing this, by train, by truck, whatever you need. Electric truck, is it a diesel truck, electric train, diesel train, so on and so forth. It is up to you to choose whatever, of course, with the distance. And in the end, you click calculate and provides you with the carbon footprint. And of course, this nice visual on what takes most amount of carbon footprint. But to take less of your time, I'm just going to show you straight away how the cross-reference works. Is by clicking this button, it opens that famous cross-referencing function that we have inside of Total Materia, inside of the horizon part. And here you can see those same things, identical official composition, actually with the same numbers. So I can tell them, okay, I need official sources. I want to work only with official or, for example, official and identical sources. And it needs to be, for example, from GB standard, American standard, AISI, for example, United States. Let's go United States, right? And calculate. So here, for example, he's showing me the same numbers for these standards. So these are all materials in cross-reference with this one, with the same calculation that we did for the 304 in the previous tab. And like this, you can also sort, see, for example, which one takes most amount and which ones take least amount. But of course, you want to go deeper down to see, for example, if anybody else has material that has less carbon footprint in the end. So this is how the CO2 cross-referencing works. In the end, if you're happy with a particular material, you want to exchange it, but also afterwards you want to compare it. And this is where material console comes in. That's the part in which you will be able to report, save, share, so on and so forth. So here, for example, we exchange the material, has smaller or higher carbon footprint. I didn't pay attention how much the previous number was. But of course, anything that you have here can also be exported, added to a list builder where you will be able to compare these two materials, so on and so forth. Pretty easy. If we don't have particular data or no data is available, usually global averages take part, especially for polymers. That I must say as well. But everything else, of course, it is selectable. So this is how carbon footprint works. Let me go back to the presentation. Open this and this. There we go. So now the question is, would you like to play around with it? Of course, every company wants to test, do we have exactly what they need? Is it eco-event? Is it not eco-event? Which numbers do we have? How does it compare with the data that we already have, and so on and so forth? Everybody's interested to sit down and actually give it a try. So here is that poll of, would you like to actually sit down with us? We open you a test account and you tell us if this is of something of interest, yes or no. And well, in the meantime, I'm going to check if I missed any. Is it possible to put carbonizing heat treatment processes in the calculation? Honestly, I don't know. I would have to check just like you. So in the end, when you actually have the test account, you can check that by yourself. Or I can check this afterwards and I can reach out via email as well. Right. Marvelous. Okay, I'm just going to wait a few more seconds to see if everybody else answered, but so far so good. If it's not your thing, it's absolutely fine. We'll share you the presentation, we'll share you the video, so you will be able to reach out to whoever is responsible for something like this. And in the end, if you want them to sit down and actually take a look at this, of course, we'll reach out to you and we will know. There we go. So what comes next? Next is exactly that. After this webinar, for those who want to sit down and give it a try, test it out for their own purposes, here is my email, here is my phone number. So if something is urgent, you can straight away reach out after the webinar. We'll sit down and speak with you. Otherwise, I will reach out via email. So I need to compile this file in which you will have the presentation, questions and answers if anybody asks a particular question that I haven't answered. We'll sit down, organize a testing account, go over your use cases, let you play with it, and in the end, it's on you to validate if you want to continue with this tool, yes or no. And then afterwards, of course, if it is yes, you will be able to start using it straight away. So thank you everybody who joined. I'm sorry to overpass this by 7 minutes. I hope this answers most of your questions, and I'll talk to you soon. Cheers, everybody. Bye.